Hello guys, today we start our journey with Spring 3.0 and I'm going to show you some simple CRUD application using Spring Boot 3, and I show you also a model mapper, and I also going to show you a Java record, how to use Java records with Spring. So we start our application with start.spring.io just to initialize our project. Today we use Gradle as our build system because usually we use Maven, but I wanna just show you the example using Gradle. We also gonna use Spring.3.1.2, the latest stable version, and that's it. Java 17, since Spring version 3 requires Java 17 as the smallest version of Java. So let's just generate our project. Let's go with group, artifact, and other stuff for our project. You can name it whatever you want. I'm just gonna show you some examples. So I gonna call my project like CRUD app example. I select my package name. I usually use two level packages like com.example, and let's just add our dependencies. So what are we gonna use in this tutorial? We will use Lombok as usual, just to avoid boilerplate code. We also gonna use JPA because we're gonna store some data in our database, and to use a database and to avoid installing database, we're gonna use in-memory database, just H2 database. And we also gonna use web features, Spring web features, including RESTful web services. And I guess that's it. Let me just recheck it. Lombok data database Spring web. Okay, let's click generate, and meanwhile we will add some additional dependencies if we need them. And let's open our application using IntelliJ. Okay, here I opened my project generated with Spring Starter. So we have the familiar structure of my project, and let's start with some entity classes. Let's create new package and call it entity. And today I'm gonna work with cars. I just selected this domain. Let's say I want to store car entity and some data about car like model, year of manufacture, and brand. So let me just create car entity. Anyway, the domain is not important for now. You can use any domain you want. I use car entity just because it sounds familiar for me, and I guess it will sound familiar for you too. But anyway, you can use any domain you want. I will show you this example, and you can use this example with any domain you need for your purposes. So let's just use annotations to make our class car entity a real entity. So first of all, we're gonna use entity annotation, and we're gonna use a table annotation, and let's call our table car table. And let's generate getters, setters, and other boilerplate stuff for our car entity using data annotation from Lombok. And let's create some fields. First of all, ID field. We're gonna say that our ID field will be auto increment, and we make it private long ID. And let's create column and call it model and year of manufacture. Okay, and we also need a brand for our car. For example, brand Tesla, Model X, and year 2022. So we need a brand, but I wanted to show you different relationships between tables. So I'm gonna create brand as not as just field for our car entity, but a separate table in database, just to show you the relationships between car and brand as many to one. Let's create another entity. Let's call it brand. Maybe you want to store not only name of the brand, but some additional information like website of the brand, maybe some address of the brand, maybe some additional information like logo or something like that. So let's just generate the same annotations. Let's just add the same annotations as we used for our car entity. So we're gonna use entity table, and let's add data annotation and create fields. Let's copy ID field because it's gonna be the same. And what else? Let's just add only one column. Let's call it name. But again, you can add as much fields as you need for your brand entity. Let's just add our relationships. So we created brand entity. We need to add relationships to the car. So we create every car has only one brand. We just create brand entity brand, and we need to add specific annotations to show that our entity car and brand entity, they are related as many to one. So we use many to one annotation from Java parse instance, and fetch type as lazy because I don't wanna get my brand entity every time I'm gonna use car. But anyway, if your entity is quite small like mine, you can use annotation type eager. The difference between lazy and eager is that you if you use fetch type lazy, when you select car from database, car entity, it doesn't fetch the brands from the brand entity table. But of course, again, if you need this brand entity, it will fetch you, Hibernate will fetch you the brand entity using join. And cascade type as let's add persist because we want to add brand as soon as we added car, for example, and we also want to edit brand as we edited car. And also we don't want to delete brand since we delete the car because this brand can be used by other car. So here are our entity tables. The next level is repository. Now let's create a package. And since we use data JPA from Sprint, we just need to create interface and call it car entity repository. Extend JPA repository, and we specify our entity and private and primary key is type is long. And let's add another repository. Okay, here's our repositories interface, and we are good. And let's add another level is service. Let's add car service, and also let's add implementation of this service. Let's add new package IMPL, for example, and we want to separate our implementation classes from the interfaces just to make the code more clear. And let's add car service IMPL, which implements car service, and we're gonna mark this class as service using annotation from Spring. We also gonna add required Rx constructor from the Lombok just to be able to auto-wire our dependencies through the constructor to avoid auto-wiring through the fields. And here we are ready to create some methods. Okay, let's just, since we are using our CRUD as example, CRUD means create, update, delete, save. And to avoid using entity classes in the layers, let's create some DTO classes. Let's create package and call it DTO. And let's create a new class, car DTO. For now, let's make it as empty without fields, because I want to show you how we can use Java record for immutable classes. Let's save car DTO, and our save is void. Okay, save for our car creation and updation. We're gonna use the same method for update and create car. We're gonna list all cars. And by ID. And let's add another method, delete. Okay, here we have our 4 methods which we're gonna implement in our car service. Let's close all and go to car service IMPL and implement our methods. First of all, we need our car repository, and let's auto-wire it through the constructor. So we make this field private final, and Lombok we add it to the constructor. And also we need brand repository. Okay, and to avoid creating mapping, we're gonna use Mapstruct. Mapstruct is a library which allows you to map between our entity classes and DTO classes using just interfaces and annotations without creating a lot of boilerplate codes. So first of all, we need to find a dependency for our Mapstruct library. Let me find it out. What can we do? We just go to the Google and put Mapstruct Maven. We select the latest Mapstruct from the Maven repository. And since we use Gradle, we copy Gradle. And where is our IntelliJ? Let's navigate to the build Gradle and add our Mapstruct. And since we use annotations, we need annotation processor. So we add annotation processor for our Mapstruct. So under the Lombok, since we're using a Lombok library and Mapstruct, we also need to make sure that our Lombok library is going after the Lombok library in the dependencies for build Gradle. And let's add annotation processor. And I guess we are good to go. Let me refresh. And let's create another package and create new class, which we call car mapper, only it will be interface. So to show that this interface is gonna be mapper, we're gonna use a mapper annotation from Mapstruct. and we're gonna specify some additional configurations for our mapper. We're gonna specify component model. Component model gonna be Spring, just to be able to hotwire our Mapstruct to the bin Spring beans. So we're gonna use mapping constants and component model and Spring. And our car mapper will behave as a simple Spring bean, and we're gonna say unmapped target policy as ignore, just to ignore fields which we can't unmap. Reporting policy ignore. And let's just create methods car DTO from car entity to car DTO. So we're gonna map from the car entity to the car DTO, and we also gonna map back from the car DTO to car entity, and we create the responsible method for it from car DTO to car entity. Okay, we're good to go. Let's get back to our car DTO, since you remember we put it as empty, and that's why, because I want to make this car DTO as record. Since Java 14 it was introduced the record function feature, which allows us to build immutable classes using record keyword. So instead of class, we're gonna use a record, and our car DTO automatically becomes immutable. So it means that only one instance of this class can be created, and if we wanna change the parameter of this class, another instance will be created. So we can just change the behavior for this class. As usual, Java object, it's immutable. So we have to stick to specific syntaxes and naming convention for our car DTO. We're gonna show you, let me for example show you how it will be on class. Let's assume we wanna have fields like brand and model and integer year. Okay, and I forgot ID, sorry. Here's our simple DTO. So we want these fields to be our fields for DTO. As you can see, we won't just show brand as name of the brand. We don't need all the table. And we can use record and put these fields into the curly round brackets. So we put long ID, and we put string brand, and we put string model and integer year. And we can be sure that Java will generate for us getters, setters, equals, hash code, and toString. So we don't need to create a lot of boilerplate code if we want to use this class as simple record. And this is the purpose of this car DTO. It's just a simple record to save the data for our class, transfer it from controller to the service layer, and convert it to the car entity, and back from the car entity to from the car entity in service to the car DTO in controller, and show it to the client. So this is the purpose of the record in Java, just to store some information and don't use any functionality inside the class. And we also would like to add some validation. For example, if we create car, we don't want to store brand, model, and year as empty fields, for example. So we're gonna use a JavaX validation, and record allows us to add annotations for these purposes, the same way as we did in our DTO classes previously. So first of all, we need to add dependency for the validation. Let's find it on the internet. And let me navigate to the internet and find a Spring validation. Go to the Maven. Since we use Gradle, we select for the Gradle and we navigate to our build Gradle and add our dependency for Spring Boot validation. We don't need version here. It will take our version from the this params, Spring version 3.1.2. Okay, let's save, and let me make it the same as the same view. It should have the same view as my other Spring dependencies, so we need just put like this. And we are ready to add our annotations to the class. So we don't want brand to be null, for example, and empty. So we can use annotation not empty from the Java Jakarta validation. If you navigate to this annotation documentation, you can see that annotated element must not be null nor empty. That's exactly what we want to achieve. And we can add our specific message if, for example, this field is empty. And we can say that car should have a brand. And of course, we want to label model in the same way we did with brand. So we're gonna say car should have a model, and year should not be null, for example. And we are good to go. Let's navigate to the car mapper, because as you can see, we have brand, but in our entity we have, let me check, we have brand but as not as string but as brand entity. So we need to use additional configurations, additional annotations in our car mapper to make sure we map correct from the car entity to the car DTO and back from the car DTO to car entity. And I see that I used misspelled entity, and let's first start with from car entity to car DTO. We're gonna map to specify your custom mapping. You need to use mapping annotation and specify target. As you can see, we use in car DTO, we use target, but in car entity, we use year of manufacture. We use year, but in car entity, we use year of manufacture. So I deliberately used this different naming of fields just to show you how we can use our model Mapstruct to map from different fields, field naming. So we say that our target is year, this one, and our source is year of manufacture, and model mapper will map from the year of manufacture to the year. And we don't need to write this code explicitly. We just add annotation. And another field we're gonna map is brand. We say that in target we have brand. Here it is. But in the entity we have in target we won't just have brand name, this field, but in entity we have all object. So we're gonna say that brand will be mapped from the brand dot name, and that's it. We just gonna use dot just to show you the brand in the car entity, name of the brand, and name of the field. And back to the method from car DTO to car entity, we want to map from the year of manufacture to year, and from the brand. And for now we don't want to map brand because we add additional functionality for brand mapping in our service. So we want to ignore the mapping of brand. We put ignore as true, and our mapper will ignore brand field in the car DTO and won't map it to the car entity. And that's it. Here is our mapper. And we can get back to the car service and auto wire our mapper. And let's implement our methods. First of all is save. And save, we need car entity. We can get car entity from the car DTO using car mapper. And here is our entity. And of course we can select brand from the brand repository by name, but first of all we need to write this method in the brand entity repository. So we say optional brand entity find by name. We use Spring Data JPA just by writing the name, and Spring will convert this name of the method to the SQL and execute SQL query in the database for us. And Spring will just split this naming by the find by name, and we'll understand that I want to show to find brand from brand table by field name. And let me just get back to the service. I say brand repository find by name, and I can use car DTO brand. As you can see, since we're using record, we have getters and setters, but it's not in the way we used to see it as getter, get brand, get model, set brand, set model. We don't have setters, by the way, because it's an immutable object. We don't have get in the name of the methods. We just have the field name, and field name uses like a method. So if you want to get brand from the car DTO, you just call brand method, not get brand. Okay, and for example, if we find by name and we don't find the brand entity in the database, we can create new one, right? We can use or else, since it's optional. We can use or else just to create, for example, new brand entity with the name on it, car DTO brand. Of course, we don't have a constructor in our brand entity just to accept the name of the brand. It's easy to create it since our brand entity is just simple class. So we create our constructor. Just to initialize name field. So if we don't find our brand entity in the database by the name, we just create this entity by the name, and we will persist it in the database. And our Spring Data JPA implementation, it sees that ID is not present, and it will create new entity in the table. And if ID will be present, the new entity won't be created. That's the magic of the implementation of Spring Data JPA. So let's just I'm not sure how many functionality we will use in the future, so we can create no args constructor just to make sure that we still can create no args. We still can use no args constructor for our brand entity, and we can also create all args constructor since it's just two annotations from the Lombok and it costs us nothing from the development perspective. And of course you can avoid creating these constructors because for now we don't need them, but since in the future, since we created our brand entity custom constructor just for name, we would like to make sure that in the future we will have constructor by default in case we need it. And let's get back to our car service implementation, and here is our brand entity. That's why I didn't want to map our brand in the car mapper. That's why it's ignored when we map from the car DTO to the car entity. And let's just set car entity, set brand, and we set brand entity. And as of now, we can just save. We can call car repository and save. And again, if car will have ID, our car repository will update the car. Otherwise, new car will be created in the database. And the next method is find all. I'm not gonna show pagination in this example. We have another video for these purposes. Pagination will complicate and our video will be longer with the pagination. So, but anyway, it's better to add some paging and sorting to the find all method. But this time I'm gonna just show you find all simple without pagination. We're gonna call a car repository find all, and we're gonna stream through it and convert through the entity to the DTO. And let me call it car mapper. From car entity to the car DTO, and we're gonna collect it to the list. And we can just get rid from the lambda, and that's it for our find all method. Find by ID can be the same as easy as find all. We don't need to write additional functionality in car entity repository since repository already has methods like find all, find by ID, because we use Spring Data JPA. So I'm gonna call car entity repository find by ID, and I'm gonna pass ID, and in case car entity repository find by ID returns me an optional, so I can say that in case I didn't find the car by ID, I can throw my custom exception, but before I throw it, I need to write it. So let me navigate to the package structure and create new package, and let's call it, for example, exception, and create new class exception, custom exception, not found exception. Let me create new class, and I'm gonna extend it from runtime exception And what information we're gonna store in not found exception? Just some message. So I'm gonna store our message, and I'm gonna create constructor. And you know what? Let me just add all args constructor, and let me add method. Just override get message from runtime exception and return our exception. And here we are. And we need to use our not found exception. Here we call if we didn't find any car by ID. So what can we do? We can throw new not found exception, and let's pass some message. For example, car not found. Something like that. Okay, looks good. And since we since we need car DTO, we need to use mapper, and we use car mapper from car entity to car DTO, and we put our invocation of the repository inside this car entity to car DTO. And the last one, delete, it's easy since we also have the method for delete in our car entity repository. So we're just gonna call it delete by ID, and we pass ID. That's it. And looks good. Now let's navigate to the structure of our packages and create new package and call it controller. And as you can guess, in our controller we're gonna store controller for our car. I call my class car controller, annotate this with rest controller. I required all args constructor, and I can set request mapping as car. Since we dealing with the car, I'm gonna annotate this request mapping as car, just to put a car URL to all methods which are related to our car. In our car controller, we're gonna use only service layer, so I auto-wire my service layer. And first method is, let's just create get mapping. Let's implement first method, get car by ID. I'm gonna use placeholder for the ID. And I don't remember the naming. Let's navigate to the service by ID, find by ID. So I'm gonna duplicate find by ID to have the same naming in the service and in the controller, just to make code clearer. And path variable long ID, and I'm gonna return car service find by ID. And let's navigate further and create find all and list. This method will be responsible for returning all cars. So I'm gonna call car service find all, and other methods like create, and let's just return some status. So we're gonna return response entity and void. We don't gonna return any object back to the client. We're just gonna return the status of the request. So I'm gonna call it save, and I'm gonna pass body, and my request body is car DTO, And since I'm gonna validate my car, I add validated annotation, and my annotations will be applied since I use this annotation. And let's call my car service, save car DTO, and in case I don't have any exception, I can return response entity created status. It means that I successfully created my car entity. And delete mapping for car to delete the car, and I'm also gonna use pass variable just to accept car ID and pass it to the service. I'm also gonna use a void and in case I successfully delete it, I'm gonna return status OK. Okay, seems fine. I suggest to start the application and see what happens. Let me navigate to the main class and run the application. And since we have a small application, it won't take to start this application to start long. Let me check what we have here. Cost annotation property car entity brand is not a collection and might not be one to many, many to many. Let me check. Maybe I misused the annotation. Let's navigate to the car entity, and yeah, sorry, I used many to many, but I need many to one. Just I guess IntelliJ IDEA auto-completed and I didn't notice it. Let me restart the application and check if it starts, and it fails once again. Why so? Build failed. I guess maybe I used some annotations incorrect or something like that. Let me check. And as you can see, we want to use a car mapper that could not be found, and it can be because I didn't add all dependencies for our Mapstruct. Let me add some more dependencies from my previous project, and let me add Mapstruct, something like this. Here's my Mapstruct. Let me replace it with Mapstruct annotation processor for Mapstruct and Mapstruct processor, and also let me add Mapstruct processor. I guess it fails because of this. Let me restart. Yeah, our application started successfully. Now let's open Postman to trigger some requests and see responses. And here's my Postman. I already prepared some methods, and let's try to send. For example, let's get by ID. Here we see localhost 8080 car 6. By the way, I don't know if you noticed, but in my application properties I haven't specified any configurations. So because I use h2 spring.30 already knows that it needs to connect to the proper database in h2. It needs to run the h2 in-memory database and connect to it. So I don't need to specify any configurations in my application properties. and also I use default port as 8080. So let's just call get by ID, and we can see internal server error. That's because we didn't find any cars. As you can see, we see exception car not found by ID 6. As of now, we didn't specify any controller advisor, and that's why we see this ugly error message in our Postman. But in 5 minutes, I guess we will specify controller advisor, and we will see pretty error message in our Postman. For now, let's try to create some car. Let's hit the send. For example, we want to send brand Tesla model X, year 2020. Let's hit send. As you can see, status created, so it means that we successfully created the car. Let's trigger all cars. As you can see, here's our response, ID 1, brand Tesla, etc. Let's just call the get by ID and check if it works. As you can see, everything is fine. Let's create another car, and for example, model Y, and hit send. And as you can see, we successfully created second Tesla. And since we don't use ID, we just create. For example, if I hit send many times, I can see that we creating our cars in the database. And if I want, for example, edit car with ID 1, I can just pass my ID field, and let's change, for example, the year from 2020 to 2022. 2022, for example, hit send, and if I click find all, I can see that my first entity with ID 1 has updated the year, and we haven't checked our delete method. Let's delete car with ID 6. I just pass 6 in the path and hit send. As I can see, status is OK. Let's check if it's true. Yeah, as you can see, we successfully deleted car with ID 6. And if I want to delete first car, I just pass 1, hit send, and as you can see, first car is deleted. So let's add some more functionality to our application, just to we haven't checked our validation. What if I don't specify the model? I hit send and I can see bad request, status 400 bad request. Unfortunately, I don't see my message which I have specified. It only appears in my logs. As you can see, I can see this message, a default message, car should have a model. It's not good. Let's specify our custom messages to be able to see custom error messages in our Postman. Let's create a new class, ControllerAdvisor. And in ControllerAdvisor, we're gonna handle exceptions, all exceptions in our application, and return these custom messages to the client. So to make our class ControllerAdvisor, we use annotation ControllerAdvise from this Spring, and we create methods to handle exceptions. For example, if I want handle not found exception, my not found, I create method to handle not found exception. Usually, let me close other tabs. We use this naming convention for such methods. We call it handle and the name of the exception. And let me make it public, response entity. And since we want to return our custom message, we need to create a custom DTO just to be able to return back to the client our message. Let me add data to generate fields, and we're gonna return only message which says what went wrong with that exception, and I don't know, let's return a local date time just to show you when it happened. How can we call this field? Let's call it time. Okay, and let's get back to the ControllerAdvisor, and we are gonna return our error DTO, and we gonna have this not found exception. And we are gonna handle it. And to show our ControllerAdvisor that we want to handle only not found exception, in this method we need to specify annotation, exception handler, and specify which annotation, which exception we wanna handle. As you can see, this value can accept array, so we can specify many multiple exceptions in one method. And let me return a response entity, bad request, and with body. And you know what, let me get to this error and use builder annotation from Lombok. Builder annotation makes our error DTO as builder. It's a pattern which allows us to build this object in an efficient way. So we gonna use error DTO builder build and specify fields like message, exception get message, and time. Now let's align our code. And we have specified our exception handler for the not found exception. But what about exception for this validation? We want to override default Spring message. As you can see, it has also timestamp, status, error, but it's not efficient for us. We want to see our message, which we have specified in this CRUD DTO, in this annotation. So we want to check which exception we need to override. As you can see, we have method argument not valid exception, and that's exactly the same exception we want to override. So we get back to the ControllerAdvisor and make exception handler value, and we want to override this method argument not valid exception. And we also want to return our custom error DTO, and we are gonna show exception for our client. And let's copy paste, but instead of message, we need to make some additional steps, because as you can see, message is quite of big for this method argument not valid exception. As you can see, this message has quite a lot of fields, and we need only default message field. So we need to go to this message and get exception, get field errors. We're gonna stream for it, and we're gonna get only get default message. And since default message is also array, as you can see, this square brackets, so we're gonna join it using collection joining. And we can get rid of this lambda using method reference. and let's align our code. Perfect. Let's restart the application and see if we can handle this exception successfully. Let's get to the Postman, and as you remember, we received previously bad request with this body. Let's hit send once again, and as of now you can see we receive exactly the same message which we specified in this car detour. So if, for example, I specify incorrect brand like this, I will receive car should have a brand, car should have a model. As you can see, since we joined and these messages are split together, we can handle this like that. We can join by comma, and then we will receive our error messages comma separated, and we can use any delimiter we want. And let me get back to my get by ID, and as you remember, when we received 500 when we didn't find the car. Let me hit once again, as of now we can see a pretty message that car not found by ID 1 and the time when it happened. Okay, and I guess that's a good work was done for this application. And I want to show you one more thing for our application is a filter. Why do they need filter? We need filter for many purposes, like we can handle incoming requests, we can modify outgoing responses. In this example, I want to show you the filter for logging incoming requests, just to see in the logs which requests we receive in the application. Let's create a new package, call it filter. Let's create our class. Let's call it LoggingFilter. And to make our class filter, we need extend. For example, once per request filter. It's a class from the Spring which triggers once per request. And to enable this class in our context, we need to make it as a bean, so we can add service or component annotation, whatever annotation we want. Let me add just component, and to enable login, we can use Lombok SLFG just to use login functionality in our code. So I can right now call log info and specify message something like that, handling incoming request. And what I want to specify is URI, and I can get method from this request. So I guess request get method, and I continue my filter chain. In case I have more filters like that, so I just pass my filter to the filter chain just to continue this filtering. Let's restart my application and see if it works for now. Let me trigger my, for example, car by ID. As you can see, we have login filter, handling incoming request, car1, and method get. And I guess it's pretty interesting. It's pretty useful for debugging purposes of your application. And for example, let me hit send all, and let me. It's strange that brand is null. Okay. And let me check my incoming requests. As you can see, car post get, and it's strange that brand is null, and that shouldn't be like that. Now let me check what happened. Brand is null. Let's hit send once again. I can see that we have brand here. Let's hit send. brand is still null. It's strange. I see that we have specified ID. I guess that's the reason why brand is null. Let me, you know what, let me restart the application. And if we want to create our first entity, we need to not to specify ID for our purposes. Let's hit create and let's select. Yeah, as you can see now we have our brand. I guess this is because of the let me navigate to the car entity, because of this cascade type. I'm not sure. And what else we can add to our service? For example, we want to make our database, to fill our database with some default data, and we want to execute some scripts, for example, for table creation or inserting some data, which can help us to debug application or something like that. So a Spring Boot allows you to do this by adding a file, SQL file to the resources. You can call it import or data, and Spring automatically will trigger requests for your data. Let me create new file and call it import SQL. I have already prepared some SQL statements. Let me copy paste it. And as you can see, I have in the brand table, I have filled brand name. So let me navigate to my brand entity and change my name to the brand name. And this is just some data insertion for my brands and cars. And if I hit trigger if I restart my application, my data from import SQL will be automatically populated to the database. I can check this by calling get all cars, for example. And as you can see, I have all data populated. And that's all what I wanted to show you today. I guess I hope this lesson was really helpful for you to reveal for you some functionality from this Spring Boot. Maybe reveal some functionality for mapping and for Java records. And I see you soon, guys.